Let's start with a fairly simple example of this. I'm just going to take a variable and an absolute value case and talk about its number. The absolute value of x must be greater than 6. Let's approach this the same way we approached it last time by considering actual values I can throw in to see what we get. Now, there's my number line. There's 0, there's 6, there's negative 6. Let's talk about some numbers we can plug in and see if they make the statement true, like the number 0. Is 0 greater than negative 6? No. So 0 will not be a solution. How about we try negative 7? Is that a solution? Negative 7, stripped of its sign, becomes positive 7. Positive 7 is greater than 6. So that's definitely going to work out. How about positive 7? Same logic. Positive 7 stripped of its sign. Positive 7 is greater than positive 6. There we go. How about 5? Let's try 5. Positive 5 stripped of its sign is positive 5. Not greater than 6. In fact, as I keep trying points, I'm going to notice that these numbers outside check out. So that means I'm going to use the word or. If I look at my picture, this matches with what we talked about for compound inequalities using the word or. So I can write this as two separate inequalities. X is less than negative 6, or x is greater than positive 6. That's what this inequality shows. It shows me numbers less than negative 6 and greater than positive 6. So what I can do with this now is I can start to use this as a tool to split those inequalities when I'm dealing with an absolute value greater than a number. Let's take a look at an actual problem that uses this. This problem is another good case of that absolute value happening. Remember, our first goal, whenever we see an absolute value as marked by these bars in a problem, is to get that absolute value by itself. That'll then let us start to work our way down the problem. Now, I'm going to subtract 4 from both sides, which is going to give me the absolute value of x minus 2 is greater than 3. Keep track of my steps. I subtracted 4 from both sides. Now the absolute value is isolated, so I need to split my cases. In this case, the absolute value is greater than a number, so I'm going to use the word or when I write this. So I have x minus 2 is going to be less than negative 3, or x minus 2 is greater than positive 3. When I write down what I did, I'm going to write down split case for absolute value. So I'm allowing for the fact that absolute value has these two cases. Now let's finish off the problem by adding 2 to both sides. I'm doing that in both of my inequalities, because it's the same thing for both of them. So I'm adding 2 to both sides of that inequality. This gives me x is less than negative 1, or x is greater than 5. So now when I draw the number line to graph this, I've got negative 1 here, 0, 5. Open because it's not equal to. I go this way for negative 1, this way for positive 5. Again, what makes this problem stick out is the fact that the absolute value is going to create this compound case. With the compound case, I then have to deal with my graph. It's a little bit more interesting. All right, I think that's a pretty good start. When you come into class, we're going to be kicking off with our first U-try in this category. Remember, if the absolute value is greater, we use the word or. If it's less than, we're going to use the word and. If you can remember that, and you can remember the absolute value means we split our case into two, should be pretty good to go. We'll see, won't we? Have a good one.